A warm welcome to everyone from Christian and from my side. We are presenting today the EUMeTrain monthly weather briefing, and I will start with the briefing and will hand over to Christian later. We will first pick up the weather scenery of Europe around the date of the last meeting that was given by Pittery from the FMI. And well, just have a look what happened during those days, the middle to the end of January until now. So we had a lot of storms this winter season, and even especially in January. So here are only a few of them named, like Storm Harry, Ingrid, Joseph, and Christine at the end of January, and Leonardo and Martha in the early February. They caused a lot of huge flooding and major damage. We will start with these weather events. Here you can see, first of all, the Guadalquivir River in Cordoba, and you can see that the riverbed here is full of water, at least. And there was a lot of precipitation the days and weeks before. And on the right side here, you can see if you're going to the edge or the corner here of the bridge bases, you can imagine how depth the water here is, or the river here is. Quite to have a quick look. Quite to have a quick look. Let me show it here. You can see here the stairs, just to imagine how depth it really is normally. You can see there is not so much water in this river. So it was a lot of precipitation that appeared here around. Yeah, so let's continue. First of all, with Storm Harry, not the first storm for that season, but for our monthly weather briefing. Very interesting. It was very special in that case. It influenced the weather around Portugal and Spain around the mid of January to well, the end more or less of January, and it was formed as a cutoff low or a dana, so this the so-called depression aislada and Nivel Altos above that area here. There were, well, for sure, some weather events like wind gusts and precipitation. You can see here that was more to the direction of Tenerife with 130 kilometers per hour with maximum wind gusts, and precipitation there at not at all 35 liters per square meter. But what was interesting about that storm, that as you can see it here, the arrow just forces your view here to the center. There was some kind of eye, at least, building up here above the Mediterranean Sea. So this storm was very interesting in its development because, as you can see here, it was so-called as a medicane. So it transitioned from a standard mid-latitude low into a tropical-like cyclone. As you know, it's very similar to those ones that we announce as cyclones, but in the Mediterranean area, therefore a medicane. When we continue here to Storm Ingrid, as it was named international, this here was a naming by the Free University of Berlin, Leonie. It appeared between the 20th and 25th of January this year. Storm Ingrid, as you can see here, is a very ideal storm, as you see from the cloud formation here. But what is interesting, therefore, for sure for the areas here, for the region here, there is precipitation, and there will be some kind of wind gusts that can cause damage. But as you look here to the southern parts, the moisture transport here is directly to the coast of Portugal and even to the northwest of Spain, at least. And what happened here? Well, in Portugal, the alerts were given out as prediction of 15-meter wave sets and gusts of 100 kilometers per hour. So if you look here at the ECMWF wind barbs and significant wave height, you just can imagine that the transports, that was nearly the whole time, not even for that event, just generated waves up to 5, 6, 7, and 9 meters in the significant wave height. And you can see it affected the whole area here in front of the Iberian Peninsula, as you can see here right now. So I think the prediction was 15 meters here was very well done, at least. So the next two storms, Joseph or Marilu and Chandra or Norma, you can see them here. They're just another two storms here. You have here some facts about them issued by the Spain National Weather Service for Galicia on the 25th, with precipitation of more than 120 millimeters in 12 hours. And even from the Portuguese National Weather Service, we had some announcing of risk of river flooding, and for sure wave peaks here predicted with 12 meter and wind gusts around 100 kilometers per hour. What is important here is these two continue in the order of several storms that appeared before. So you have to keep in mind that the ground just had to take a lot of precipitation, a lot of water during the last weeks before. And that makes the situation very dangerous and difficult. We had at that time the maximum wind gusts at Wales, Morfa Nefyn, were about 117 kilometers per hour. So now just keep in mind the two storms before, and after them, or nearly after them, appeared Storm Christine, that period at the end of January. And this one was very special. As you can see here, it's a geocolor RGB MTG, more or less the same kind of low that was, or that developed, but it's a little bit different, as it was generated by a baroclinic disturbance of the other ones, as we can see in the following slides coming soon. There was a trough in the jet stream, and this one introduced an explosive cyclogenesis. So it is also coupled with an event we call sting jet, when it had landfall. When it had landfall here around Leiria. So this wasn't in the prediction at that time, but it happened at least with all the results and effects. So if you look here on the right side, you can see the MTG night microphysics image. And you can see that the whole cloud screen, or the whole clouds were around the Iberian Peninsula here at that region. Here's the border. Portugal can be just found here, the coastline. And you see above it, we have the divergence. There's a lot of minus or negative divergence at that part. So there is some kind of convergence near this area. And if you look now on the left side, there you can see the jet stream here that is marked in 300 HPA. We have the mean sea level pressure here marked especially. And then if you look, these are the storms before, and you can see here from the west coming. At the moment, for that time, it appears only a bit. There's a small signal, but in the following hours, it just strengthened so fast, as you can see here with the trough, and comes up here. There's a development we can see, and then this is a situation where the prediction came out with the warnings, and it intensed very fast to this spot here. And you can see the landfall then appeared a little bit later. And what happened here, there was some kind of a special intrusion, we can call it. So if you continue here, I just mentioned there's some kind of sting jet. So what happened in this situation? Here we have the clouds above, and you can see here the MTG air mass RGB around these days that there is some orange or brownish color here. So it signals for this type of image that there is an intrusion of some dry and air mass, but this origins in the stratosphere, coming down to this area, to the center, more or less, of this low of storm Christine. So this means that there will be a strong wind field with all the effects. So for Portugal, here are some facts about that. It was the strongest storm ever measured there. We had wind gusts around 208.8 kilometers per hour in Sur, Portugal. And at the Montreal Air Base, before it was partly destroyed, there were taking measurements of 178 kilometers per hour for the gusts. It was put into the categories between category 2 and 3 of the Saffir-Simpson hurricane wind scale. So it was a very, very strong storm that appeared there. And Nuno Lopez from IPMA just wrote down this, or gave out this. The situation we sometimes call a small meteorological bomb. These small cores sometimes have an associated secondary zone of great intensity, which we call a sting jet. So just have a look on this. I've taken here a little bit of the material of the EUMeTrain learning materials. So you can see here, it's not the same scenery, but the formation's more or less the same. We have a warm front here. There's a cold conveyor belt at that side. And to the south, we see here's a cold front. The air mass is coming from here, normally from here, and here is the center where the merging starts of everything. But there's also some kind of dry intrusion that leads directly to that center where the bandback warm front appears here. So if you look at the conceptual model, at least you can see like it is marked here with SJ in that center. And if you see on a conceptual cross section here, you can see it origins in the stratosphere, coming down to the ground, and in this area it causes the most damages ever, therefore. So it's strengthening incredible the wind field, therefore. I just wanted to see what happened there around and had a look for some news sources and image sources. I found this image here, this photograph. I wasn't sure the first time when I have seen that. It looked a little bit like AI created, but I could verify it with other sources. So if this is a reality, it's very crucial, I think, what happened here, as you can see, the force of the wind that appeared there. So let's go on. Another image here by Sentinel-2. You can see at the coastlines here, at the Portuguese coast, there are always waves breaking at the coast, so you can see this clearly, and even the waves in front of the coast and the flooded area here that appeared brownish-like. So the whole event hit, I think, Portugal very, very hard. If you continue here, we have another interesting storm at the beginning of February. It was called Leonardo, International Leonardo, Steffi by the FU Berlin. We can see here the center more or less, and on the surface pressure map here, as it is drawn here or shown here, a very long front around this area here. I think what is important here is just to have a look how it is combined with how the air masses are combined here with a storm center around nearby northwest Europe, going up to the Atlantic Ocean, to the middle and more to the western parts to the Atlantic Ocean. So if you have a look here, therefore, you can see similar how wide and how many kilometers this must be, at least, for a transport mechanism in the atmosphere. And we can see here also the wind speed at the Atlantic Ocean was very high in the atmosphere. at that time, and it was typically for that storms that appeared in the winter season. The direction was straightly towards here the Iberian Peninsula, straightly towards to Europe at least. Even just have a look here to the entrance of Gibraltar to the Mediterranean area. So what was predicted then were some warnings, extraordinary danger with exceeding 250 millimeters in just 24 hours were predicted, and even on grounds that were still flooded. You have to keep that in mind. So the grounds were saturated, deeply saturated, and they would never could handle this, what then happened. So even here, you see the satellite image as before. And what you have to keep in mind, well, here is storm center, here are several storm centers, and this goes up here. And the transport goes around or above the whole Atlantic Ocean. And there we have something we can call an atmospheric river, because the transport of the moisture comes more of the region around the Caribbean Sea, the Caribbean area, and the moisture therefore is very high and the air mass is very warm therefore. So it brought a lot of humidity that is responsible then for the precipitation, at least in the area of Spain and Portugal. You also could see, caused by the wind field here, there were large waves at the entrance of the Mediterranean Sea. Here are some facts. In Andalusia, normally a very dry area in southern Spain, the rainfall exceeded 200 millimeters to 400 millimeters in 24 hours. That's quite a lot for that area. So, well, and that on a saturated ground at least. Then we can continue to the next storm that appeared after that, more or less after that. You can see there are not so many days between the storms before, but again, similar formation. We have a storm here in front of the coastline of Portugal, the Iberian Peninsula. Here the cloud formation, and even it's obvious there should be some precipitation then. IPMA, the Portuguese National Weather Service, just announced it, therefore, that there were waves around 13 meters of wave heights, and well, also very interesting now that there were 25 centimeters of snow around that event. We haven't spoken about that before, but this is very interesting for the winter season as well. The Spanish Weather Service just announced about 60 millimeters in 12 hours around the area of Andalusia. So always keep in mind the ground is saturated, so every kind of precipitation, every amount of precipitation can hardly taken into the ground. So flooding is very obvious in that time. So here we have an RGB daily accumulated image of the Sentinel-3. As you can see, the convectivity in the atmosphere for that area that was affected by that storm. So again here, it is very similar to the storms before, and you even have these small disturbances there that appear and comes up and bringing up these storms where you can see the streamlines. So wind and flooding are typically for the weeks end of January and well, the first weeks of February until the middle of February. But herefore, I have to mention there were some hints about a sting jet, but there wasn't a very good indication for it, at least. So it's not sure to combine it with that kind of event. So even just have a look at the MTG air mass, RGB, you can see also here some kind of intrusion, and also we have here the precipitating clouds and the MSLP, the mean sea level pressure here. You can see the areas here show that it was very obvious that there was a lot of, or there was precipitation, and it was too much for the ground that was saturated, at least. So even this could be seen as the SEMS, Copernicus Emergency Management Service. Here around Lisbon, you can see the flooded area in a zoom, and this is the area a wider perspective here, that all the rivers couldn't handle the water that came down. We had on this area of interest, 64,000 hectares that have been flooded at that date here. So let's go a little bit more to the Mediterranean Sea to see what happened there. One of the storms then that followed, or was, well, during that period, end of January, February, was Storm Patricia. This one was very interesting as it was more or less in the middle of the Mediterranean Sea, but it caused an extreme bora, extreme winds nearby the coastlines here. At the Creek Bridge, there were gusts of 55 kilometers per hour measured, must be in this area more or less. You can see it here by the wind field. Unfortunately, I had now better data for presenting the strength of the wind field there. But as it was combined here with the Storm Patricia, the wind field is very obvious to see as it goes up from the country inside, from the land side to the Adria to the sea. What also was interesting, and now we change a little bit, as you can see here, the day snow fog RGB. What is orange reddish like here on the ground is snow covered area, and if it is above in the atmosphere, everything that is orange like or yellowish here seen. There are ice particles in the clouds therefore, and that's very interesting. Unfortunately here it's a little bit covered, but you can see it below on the ground. There was a lot of snow at that time. That was very typically for that season. And if you look to Europe at that time, with the same day snow fog RGB, you can see it here more to the eastern parts that there was a lot of snow. And what happened here, that is very interesting, it goes up to the north around the area of Berlin. That happened that we had an event of freezing rain then there over Germany, over Berlin here. You can see this cloud type RGB by MTG. And well, the conditions here in these colors were clearly that we had icy conditions in the atmosphere, but to the ground it was kind of melting and freezing at that time. If you look at several observation stations, you're around 0 degrees or below 0 degrees, and therefore it caused, especially in Berlin, you have here some synop observations. There was then a freezing rain event that just influenced a lot of the well, of the public therefore. And if you look to Europe then on an IFS MSLP map with the air temperature and 2 meter, you can see clearly how Europe was divided at that time, that we had more on the eastern parts here, the typically cold, well, conditions, which is more or less normal for winter. Especially here in Germany, we had a lot of snow in a lot of areas that has not appeared for years at least. That was very interesting, instead of the flooding events that appeared more to the western parts of Europe. And if you look to the middle of February, we can see here that even France was affected by similar storms coming up from the west, taking the whole moisture from the Atlantic Ocean, and even from warmer and warmer areas at least. So we had here in 30 consecutive days red alerts in 81 departments, and around 154 rivers were flooded at that area. As it is marked here, it's the Garonne River, for example, as you can see. This is therefore only one example. Then, as you can see, during those days, we always had one storm after the other, bringing up precipitation to that area. So the grounds were fully saturated and couldn't handle the amount of the precipitation that happened. So yeah, here's also precipitating clouds shown during that time and the MTG air mass. Therefore, there are always these reddish-like areas marked where the percentage of precipitation is very high. If you look during those days to the news and just to have
rising,
what happened,
rivers breaching and submerging their banks.
Here.
Like here at La Herold, located between Bordeaux and Toulouse, the Gironde River has flooded the town and completely submerged roads. On the French government site, Vigicru, which monitors France's rivers and tides, much of the Atlantic coast and the southwest were orange.
This was done by or made by France 24, and you can see here just one publication as what happened in the river system here around France. So very dangerous situation at that time. And well, if you look at the EMS R866 maps there by Copernicus, you can see the flooding a little bit more in details, and show it to you here. Just if there's some interest, just have a look for these sites, and you can go very straight onto the flooded area to get more information, just to get a visualization what flooding meant in France at that time. Well, okay, so finally, this is my last slide then. As I mentioned, we not only had flooding, we also had a winter weather events like snow, a lot of snow, and temperatures below zero here around the middle of Europe to the eastern parts. As it seemed to be a very strong winter, it wasn't at least for the global climate in relation. In January 2026, it was the 5th warmest January globally, with an average surface air temperature of 12.95 degrees Celsius, which was then here 1.47 degrees warmer than the estimated pre-industrial level, therefore. And I now will hand over to Christian, who will continue with some information about the recent weather and what will happen next. So thank you from my side.
Hello, everybody. Welcome to the second part of our presentation. In this part, I would like to focus on the current circulation and the forecast and discuss whether spring conditions are developing. But at first, let me briefly introduce myself. I've been working for a general forecaster at the Central Forecast Office in Offenbach at DWT for 16 years. I'm also a member of a working group on the evaluation of nowcasting products, and I'm also in a tornado working group. In addition, I'm a trainer in weather forecasting and nowcasting. And let us continue with the last illustration which Markus showed us in his presentation. And the key question is here, where does this extreme temperature gradient here between northeastern Europe and Greenland come from? And and I think this is related to the upper level circulation, which you can see in the chart on the right at 500 hectopascal here. The temperature field is directly linked to the large scale flow. It's an example from 24th January 2026, and this is a typical situation for the winter circulation at this winter. And what you can see is here a high latitude blocking at this region near Greenland and other blocking here. And the jet stream is shifted far to the south. This leads to a very wavy jet stream, and this pattern caused the extreme weather events which Markus showed us in his presentation over the Iberian Peninsula and the Mediterranean Sea, and also over France. And there you get this extreme weather over Europe. I have also problems with my computer now. The slides doesn't turn. It's okay now. And I believe this is related to the stratosphere. In particular, the high latitude blocking is connected to a stratospheric warming event in November, which you can see in this diagram. It shows the temperature at 10 hectopascal for the winter 2025 and 2026. And here the red line are the observations, and here in this diagram is the climate. The climate mean is the yellow line, and here in green it goes into the forecast. You can also see a significant temperature increase here. We will come to this later, but in late November, you see here a major warming event occurred, and this destabilized the polar vortex and led the vortex stretching. The vortex was weakening. As a result, blocking developed in the troposphere, and this contributes to the southward displacement of the jet stream and to the cooling over northeastern Europe. What you can see in the next slide, I hope here. Here you have the cloud phase RGB, and you see a lot of snow cover over northeastern parts of Europe in this cold area, and even extensive sea ice coverage in the Baltic Sea is seen here. And warm air intrusions have difficulty establishing themselves here in this region. And let's go to the next slide in the chat. If I have still problems to change the slides. Now. Let us move to the jet stream. It's IFS analysis of the 300 hectopascal jet on last Thursday, the 19th, where the last storm happened over Western Europe, and you see a very wavy jet stream is shifted far to the south over France, and this was typical for the last weeks. And this jet stream rapidly transported strong low pressure systems into these regions, and these systems also affected the Alps, brought a lot of snow there. And you can see the last snowstorm in the cloud type RGB. Here, this vortex, what you can see here, is part of already occluded low pressure system. The yellow to the orange colors here in these clouds indicate compact clouds where heavy precipitation occurred, and the 850 hectopascal temperature were around 0 degrees at this time. This means snowfalls above 1,300 or 1,500 meters, and there was substantial additional snowfall, particularly in orographic uplift regions, with up to 18 centimeters of accumulation on top of the already substantial snowpack here. Also, some stations in the France Alps reached record values up to 3 meters or 5 meters. It was really impressive, and this was good for not always good for winter sports. You can see this. This led to a critical avalanche situation in parts of the French Alps. Even warning level 5 was issued in this region here. And there were also heavy snowfalls in Italy, in Tyrol, and in southern Switzerland here. And in the next slide, we want to come back to our polar vortex. We have here a stretched polar vortex caused by sudden stratospheric warming. It's 10 hectopascal temperature and geopotential here, and it reveals a sudden stratospheric warming event here, what you can see here on this side, and led to this stretched vortex. And it was only a minor warming, so there was no complete vortex breakdown, but the polar vortex was weakening again. And I think, I believe that has an influence on our weather. So I'm trying to go to the next slide. Sorry, it doesn't work. Okay. Nevertheless, I believe this already influenced the northern hemisphere circulation in the troposphere, as shown on the 500 hectopascal map, together with the mean sea level pressure. Here we see the tropospheric polar vortex on 500 hectopascal. It has split in Siberian part and a large sector over northern and eastern Canada, extending towards Greenland here. And the Greenland blocking has disappeared, and as a result, cold air flows over Northern America, over the relative warm Atlantic here, and here it's leading to cyclogenesis over Newfoundland and south of Greenland. And the jet stream is shifted further to the north at this time. As a result, we end up on the leading edge of the leading side of these low pressure systems, and this allows very mild air to be advected into Central Europe, displacing the cold air more to the northeast. So the next slide. This all can also be seen in the air mass RGB. The current situation shows an Atlantic trough with numerous showers on the cold side here, and here in this region. And ahead of it, a stronger upper level high expanding northwards, which you can see here. And Eastern Europe, in contrast, is still under the influence of a stronger trough, which can be seen here. In today's cloud phase RGB, you can also see this you can see here these high pressure systems in a cloud-free conditions over Central and Western Europe. Clearly can be seen snow over the mountains, the Pyrenees, which also had a lot of snow, and a lot of snow in the Alps, especially in the Western Alps. There are some fog or low stratus clouds over Central Europe here, or in the Po Valley. And there are also a lot of low clouds over Eastern Europe, and you can also see this nice developed low pressure system with this vortex here. This pattern is also evident on the 500 hectopascal map. We can identify low geopotential heights over Greenland, and a strong ridge over the Mediterranean Sea reaching Central Europe, which brings us the spring conditions, and here's the trough over the Eastern Europe. Over the next few days, the circulation pattern will change very little. However, in the north, we can already see the development of blocking at higher latitudes here. But at this time, it isn't over Greenland. It's here very far in the north over the Barents Sea. So in the next slide, you see the 850 hectopascal temperature. One can see clearly the warm air advection over Western Europe. The 500 hectopascal temperature are rising to values above 10 degrees here. Let's go back here. And this is really unusual for spring. It's more like summer-like conditions, and this leads to unusual high 2 meter temperatures. This is a model output statistics. It shows the maximum temperature on today's Wednesday. And you see in France, the temperature exceeds 20 degrees, and in Spain, temperature rise as high as 27 degrees here in these regions. And only in the northeast, the cold air persists over Europe. Let us take another look at the outlook to the next weekend. The forecast map of the weekend indicates that the circulation is transitioning towards an anticyclonic westerly regime. That is a westerly flow with a relative far northwards displaced frontal zone. So the southern and central parts of Europe will remain mainly under high pressure influence with rather warm temperature, while the cold air in the east retreats somewhat further, which you can see here on the 800 hectopascal map. And if we go into the extended range forecast of the IFS model, this pattern does not appear to change significantly in the future. The The left-hand map shows the expected mean geopotential anomaly at 500 hectopascal for the week for the first week of March, and it also indicates a positive anomaly over Central Europe, as well as a disturbed polar vortex forming a bridge across the pole here. Here, the polar vortex in the troposphere is divided in two parts. This will lead to spring-like weather with positive temperature anomalies here over parts of Europe. However, I'm not entirely certain that this pattern will remain stable. Some of the latest forecasts show that at 10 hectopascal, the polar vortex is collapsing due to the significant warming, what you seen in the pictures before, and this could influence the subsequent circulation pattern. And it often takes some time for the extended range forecast of IFS or other models to fully respond on such changes. Therefore, I would not rule out a new winterly phase for northern or northeastern Europe. For Central Europe as well, this might be the case when the high latitude blocking is shifting again in the direction of Greenland. But for now, however, the coming weeks are expected to bring spring-like condition. And with that, I conclude today's weather briefing. Thank you very much.